can the machine can know that there is no connection between the zip code and this node, for example? Okay, the way, yeah, they use for the way. But how can the machine use for the way? So first of all, we take a look at the general architecture of neural network. So in the past, there are many different architecture of neural network. But nowadays, most of you consider neural network as this architecture. This architecture we call that MLB, multiple layer per second. One node here is a per second. Why we call that per second? Because it can infer the weight. Okay, it can infer the weight. Okay, your friend tell very good keyword. They can infer that the weight here on both zero, there no weight here, for example, something like that. But in the initial setting, they will have multiple layers of per second, and they perform the so-called fully connected mechanism. That means all of the neuron in the previous layer will be connected to the next layer. There is no jumping, there is no skip connection. Later on, some advanced network they introduce the residual mechanism, but this is more advanced. So in the standard neural network, they have FC, fully connected neural network, or NLP, multi-layer per second neural network. But keep in mind that is not a single, the only architecture neural network. In the past, there are many different topology of neural network introduced. But now for the advanced, because this one easy for scientists to expand into multiple layer, just add more and more layer, and then you have the deep learning. And what is the disadvantage of deep learning? The advantage you will know later. But now, based on your intuition, what is the disadvantage of deep learning? You consider that deep learning will be multiple layer like that. So what is the possible disadvantage of parameter, the number of parameter may be large, very large, okay? And there another one more disadvantage, that is the size of the input efficient. The size of the input efficient. For example here, the input only 4 dimensions. They can accept the input less or more dimension. So to counter those disadvantages, people introduce two more popular architecture, CNN and RNN. You will study about them later. But now, just a very good introduction. But now, you will consider a very basic neural network. Okay. So, what is the mechanism of the neural network? They will have the input. Okay. That is very similar to logistic regression. First of all, they perform the dot product between the weight and the input vector. Okay, the way the input vector. So, for example, for neuron 1, the weight 1, 0, minus 1. So you see, from S1 to 1, this is 1. From S2 to 1, this is 0. 0 is no way. We don't bother. Wrong with it. Okay, and the last one, the input is minus 1. The input is the constant. The constant here we will call that bias. Okay, they always need the bias in the real neural network. Okay, you will maybe by your letter you can hear me explain why later. But now we'll have time in this class. Okay, but we always use the layer for each the bias for each layer. Okay, so from here the weight is minus 1. And then you perform the similar to logistic regression. In fact, this is logistic regression. Okay, no, similar. You perform the between the input vector and the weight. And you get the result. The result we name V. Okay, and then activate. Okay, similar to logistic regression, you activate. But in the early days of the network, the activation function is very simple. They just simply compare to a restaurant, and the restaurant being chosen is 0. That means if the V the V is the dot product between the input and the weight. If V is positive, the value is 1. And if V is negative, the value minus 1. In fact, they can choose any pair of value to indicate that whether the network activates or not. Okay, to indicate that whether the network activates or not. So in the lecture of logic regression, the value for activation and deactivation we chose 1 and 0. In this case, the designer of this network choose the value of 1 and minus 1. Okay, so the mechanism is very simple. You compare, you perform the product and you compare the value. If the value of the product is 1, the output here is minus 1. If the output is negative, the output here is minus 1. Okay, depending on the value of the total product by result. Okay, so let's see the mechanism of the whole network. And now the question is, the input is S1 and S2. S1 and S2, you can consider this is a point in a 2D coordination. Okay, a 2D dimension. Okay, so what is the value of S1 and S2? What is the value of S1 and S2? That make neuron 5 activate. Okay, the question is what is the value of S1 and S2? That can get the value of neuron 5 activate. Okay, so if we have time, I will let you do some exercise for fun. But now I will solve it for you. Okay, so you see, if the neuron 5 is the final output, the output, this is the input layer, this is the output layer, this is the return layer. So the output layer here. So in order to be activated, that means alpha equal to 1. Okay, alpha equal to 1, that means 1 half O1 plus 1 half O2 plus 1 half O3 plus 1 half O4. Okay, subtract this 2 minus 2, 3.5. This one must be greater than 0, greater or equal to 0, in order to allow O5 to be 1. Okay, so now you know that O1, O2, O3, O4, they are results of number 1, 2, 3, 4. Okay, so what is the, so that means O1, O2, O3, O4, they can only be 1 or minus 1. Okay, they can only be 1 or minus 1 because this is the result. This is the result of the activation function of the reverse network of the reverse neuron. So if you know that O1, O2, O3, O4 can only be 1 sum minus 1. So what is the possible value of O1, O2, O3, O4? That makes this equation positive. What? Oh, not number 1. Only this guy. Okay, so this only one possible solution. Okay, so what does it mean? It means that O1 is greater than 1. So once again, we consider the dot product between the input and the weight of 1. So it means S1 plus 1, right? S1 plus 1 greater than 0. So it's corresponding to an equivalent to S1 greater than minus 1. So this is minus 1. This is S2, this is S1. So greater than minus 1, that means all of S1 must on the right side of this vertical line. Okay. in order to activate O1. Okay, so similarly, for case of O2, so okay, now you know why we have this one. Okay, you know why we have this one. So this is plus, not minus, this is this type, plus. Okay, so in that case, you have similarly you have okay. So in order to make O2 activate, the neuron 2 activate, S1 must less than 2. So now there is the two borderlines. Okay, so S1 can only go back and forth between two borders here, cannot less than -1 or cannot greater than 2. Okay, so similarly here you have S3. The way how can we infer such a value? Now you understand how we can infer such a value. So for the case of number 3, it means S2 much greater than 0. That means S2 much from here go above. Okay. And the last one, S2 much less than 3. Okay. So that's the reason. That is the reason. That makes the neural network activate. Or in that case, this is the network designed to choose all of the points in this rectangle. Okay. So that is one choice example. Now we move into another more interesting and more practical example. Okay, now how we solve it. Okay, so you know how to do it. And then this is submit test and this is -1, not 1. Okay, so you see why we have the result. Okay, so now we move into another. Example. In this example, the meanings of the waves are the same. Okay, and the activation function. Okay, similarly, we also have -1 and 1. Okay, and now when you solve the problem in the similar way, you will get that the reason will be between the two lines here. Okay, you will solve the problem yourself if you are interested. Okay, but now if we determine that all of the value of S1, S2 only fall between 0 and 1. Okay, so the final reason that makes the whole network activate in between this polygon. Okay, in between polygon. Okay, how to solve it, you do it yourself. Okay, so now if you consider the input some Boolean value that means S1, S2 can only be true or false. Okay, so we indicate that 0 is false and 1 is true. So you see that if S1 is true, you can draw the. Okay, so you see S1, S2. So, if S1 is 1, and S2 is 1, okay, if S1 is 1 and S2 is 1, so the network activate or not? Okay, look at the picture. Okay, so if S1 is 1 and S2 is 1, so it means it corresponds to this orange. So if in that case the network activate or not? If you know that the region that makes the network activate only in this polygon, so this one activate or not? No. So the result is false. Okay. the result. And similarly, if S1 is true, S2 is false. Okay, S1 is true, S1 is 1, and S2 is 0 is here, the network activates. Okay, network activates. Okay, similarly here, so if you still remember some knowledge about the cluster, digital system, okay, so what is truth table? Is a truth table with something? So, okay. Okay, so you see, in the early days of neural network, they fix the weight. To design all of the circuit, all of the logic circuit they want. Okay, they can design SAW, AND, OR, etc. And they implement them at the hardware level. Okay, so the network can work very fast. Okay, but if the output is symbol like that, you can somehow manually infer the weight in contrast one weight. But in the complicated case, for example, the case of classification in the previous example we studied in the lecture of this lesson. How can we infer the weight? It's very hard. Okay, it's almost impossible for human brain to infer the weight for complicated case. So people think that in order to manually infer the weight here, they let the neuron learn themselves. Okay, the neuron will modify the weight. Okay, modification of weight is very similar to modification